So continuing our conversation about encapsulation, we hide data, any of those private methods or properties, fields, because once our class is in use, we have other people, other programs, companies, etc., who are using that class, and it's important for them that the outside of that class, the public methods and properties, are unchanged, so that the way that those classes are being used doesn't change over time. If we go in and make a change to a class and change its internal methods, we're fine. If we change the external method signature, it could break every place that that code, that class code, is used within an organization or across organizations. Next, a quick concept of stale data. So, for example, when we're considering the area of a rectangle, we could, in memory, create a variable called area and return that. And the area variable would be the multiplication of the length and width. The problem is that area value could become stale if we go in and modify the length value, but we don't remember to modify the corresponding area variable. We would call that area data stale. So what we do is when we're returning the area, we don't make an internal variable area, we just return the live value of the length and width. That way, if either of those change, there's no such thing as a stale data in that case. So we just have to be careful when we are retrieving data from the class that we have properties that are corresponding to the most recent version of that class, the most recent changes to that class. We also have a concept of instance and static. You guys will recall that a bunch of the methods we've used thus far have static in them. What that means, a static method is a method that is available essentially all the time. Instance fields and instance methods are only available, they typically exist on a class. For example, if we have a method called, for the rectangle, getArea, that method of getArea is an instance method because it only will return values and it can only be run when that rectangle object exists in memory. If the rectangle object doesn't exist in memory, there's obviously no area that we can return. So that's an example of an instance method. A static method is something like, maybe we have a static method called getTemperature or something, and it literally just gets the current temperature. It has nothing to do with the instance of any object or class, and it's just we can access it at any time. So static methods can be accessed at all times. Instance methods can only be accessed when that particular object's instance is there, is present. So for example, we have the rectangle object. We have three different instances of the rectangle object. We have a kitchen variable that's storing a rectangle. We have a bedroom variable that's storing a rectangle. We have a den variable. That's three different instances of those objects. And so if we were to retrieve the length and the width of those would be instance method retrievals. Next, we have an important concept called constructors. Constructors is essentially a method that is automatically called when you create an object. You've been using these so far. Whenever you access a class, part of the signature is when we say new, and then the name of the class, and then the parentheses, that essentially is the constructor. Sometimes the constructor takes arguments, sometimes it doesn't. But the constructor is essentially what is called automatically when an object is created. We've been using them so far, but we haven't explicitly talked about them. So now we're talking about them. And why are we talking about them? Because there's different ways when we build classes and when we call them into memory that we can create them. The constructor is going to have the same name as the class, so the rectangle constructor is going to have the name rectangle. It has no return type. It doesn't return values. They're public, of course, because they need to be accessed outside of the class. So for the rectangle class, we might want to create a constructor that allows us to pre-populate the length and width. I think earlier in our example, we had a rectangle and we just had an empty parentheses for the creation of that rectangle class. That would mean that those values would be, when the rectangle object is set into memory, those values are 0. But if we want to pre-populate, which is pretty common, we would use a constructor that allows us to enter in the length and width. So here's the code for it. We have the standard kind of function signature, public, the name of the class, which is rectangle, and then our arguments that we want to pass in this case, a double for the length and a double for the width. And we can see that those, when passed in, they are set, just as before, to the internal values, the private properties, the private fields of length and width. So when we create an object, bring it into memory, constructor's always called. If we don't write one, a constructor, Java's going to create an empty one, a default one. When the default one is used, all the numeric values are set to 0. So for example, if we use the rectangle empty parentheses constructor, which is the default constructor, it'll just set the length and width to 0. Anything that's Boolean is false, and any object would be null. So again, you've already been using the default constructor in a couple different instances. We just haven't spoken about it. And in fact, if you create a class and don't specifically make a constructor, again, Java will automatically create and use this default constructor. So again, here it says the only time Java provides a default constructor is when you do not write any constructor for the class. If you want, you can write your own no argument constructor, and that would essentially replace the default one that Java provides. Maybe in this case, we want to create a rectangle that doesn't take any inputs, but actually sets the length and width to a value that we want, in this case 1. So those are not values the user entered in via the arguments, but they are set by us. So we can do that, and that essentially replaces the default constructor. So for example, we have the string class. The string class constructor, you can see we have the string class reference on the left. Name is the variable name. New, we are creating a new instance of this class, object, string, and the parentheses, and then the argument we're passing in is, of course, the string itself. So that's an example of the constructor. Now, the string is actually used so often that there's sort of a shorthand form where we just essentially ditch new string parentheses and we just put the string itself in because it's used so often. But for class that we create, the syntax would be more new, class name, and so forth. Okay, so we got our shorthand. And then we, in addition to passing in numbers and strings, we can also pass objects in. And when we do that, we pass the variable for the object, which essentially gives the class, the internal class, access to that object so that its values can be retrieved, manipulated, etc. We also have the option of having multiple constructors and multiple methods. We can overload a method, which means we have the same method name used 2 different times, but there's different types of arguments. So in the example here, we have the add method. So in the top one, you can see that the 2 inputs are numbers, int num1 and int num2. And we sum those and return the sum as an integer. We have another example of the add method, but this one takes in 2 strings and concatenates them. So the same name but different types of inputs. When I've typically used overloading, it would be in terms of number of arguments. So, for example, maybe I want to add things, and I either want to add 2 things or optionally 3 or 4. So I might have several different versions of a function that take different numbers of inputs depending on the different case that I'm interested in. Okay, so we've got method signature. It's the method's name and the data types. It does not include the return value, but it includes the name and the type. So that in the previous example, we have the 2 integer arguments and the name, and then we have, on the bottom case, we have the 2 strings and the name. Similar to overloading methods, we can overload constructors. So we can actually have several different ways to create a class. Again, with the rectangle class, we could have our default constructor, or our constructor that takes our no argument constructor that either populates everything as 0 or populates the length and width with some default values. And we can also have the secondary constructor that allows us to input the length and width. So we can actually have as many as we want. In some places with more sophisticated classes, we might have 5, 6, 7 different types of constructors, depending on the complexity of the class. So if we were creating, for example, an employee class, and that employee class had first, last name, phone number, address, social security number, etc., we might have a constructor that allows us to instantiate the employee by name only. Maybe there's another example where we'd only need to instantiate it by social security number, and maybe there's a time when we'd want to instantiate it by the full name, social security number, and address. So there could be a lot of different ways that we want to Okay. So when we talk about instance fields, those are obviously fields that exist only when that class is in memory. Those values can be accessed by any method in the same class. If the instance field is a public instance field, it can be accessed by code outside the class. If it's a private instance field or instance method, it can only be accessed inside the class. So that's a quick look at classes. This is an important topic. I just want to summarize it. A couple of the important things we talked about are, what is a class? How do we create a class and instantiate it as an object in memory, assign it to a variable? Up to this point in the class, you guys have essentially used pre-existing classes to essentially run your code, but now you're actually creating your own custom classes. And so we're doing that. Next thing I'm gonna do is I'm gonna post an example of some code where we do that that's very similar to some of the problems that you guys are gonna be doing next week. Thanks a lot. Obviously, email me with any questions.